In today's class we are going to cover the topic cache memory addressing. When the content is in the main memory, when the content from the main memory is fetched and loaded into the cache memory, okay, so the address which the CPU generate to search the content from the main memory, the address is divided into two parts that we have discussed already: 13-bit address and 3-bit address. 13-bit address is a block address and 3-bit address is a byte address within that block. Okay, so the content which is loaded from the memory into the cache memory, the content transfer will be done in the terms of a unit of one block at a time. Okay, when the CPU generate some address to fetch out data from main memory, the address generated by the CPU, the block address will be compared here in the tag memory first. If the block address is available here, it means that the data is available in the cache memory. The CPU need not to search that content or data in the main memory. Okay, so as the data is available in the cache memory, because its block address is there in the tag memory. So what happens when the data is available in the tag memory? The corresponding bit of the valid bit buffer or valid bit array is set to 1. Okay, so every time when CPU generates the address, the block address portion of that address will be compared in the tag memory. Okay, so how it will compare? That address will be compared in the tag memory sequentially. That 13-bit address will be compared first with the first memory location of tag memory, then second, then third, and so on. If the size of tag memory is large, it has n number of locations, then for every address generated by CPU, it will take n number of comparisons. So in order to avoid this kind of situation, we came up with the solution of valid bit. Okay, so the portion in the cache memory where the content is transferred from main memory to cache memory, suppose this portion is available here in the cache memory, and this portion is available here, from here is available in the cache memory. Okay, and also this portion is also available. So what will happen in the corresponding locations? It will set to 1. Okay, so when the CPU generates the address, and that address will be divided into the block address and byte address, and the block address is compared in the tag memory sequentially. Rather than this, now with the new mechanism, the address comparison will be reduced to 3 comparisons only, because the block address generated by CPU now will be compared with only those portions in the tag memory where the valid bit is set to 1. So in this case, it will have only 3 comparisons. The block address will be compared at this particular tag memory location, then at this location, then at this location. So only 3 comparisons will be done, and the location where the address is matched, then it will move on to the cache memory location and then utilize this address, 3-bit address, to find out the correct byte required by the CPU. So this is how the cache memory make the use of valid bit and reduce the number of comparisons and make the cache access more faster. Thank you.